So we're going to transition now from Chapter 16 and the innate immune response to Chapter 17 and the acquired immune response. So in terms of that acquired immune response, remember we're starting out with our hematopoietic stem cell. That hematopoietic stem cell can give rise to either the myeloid or the lymphoid lineage. Primarily, we've been talking about the myeloid lineage with the innate immune system, with the basophils, eosinophils, neutrophils. The myeloid lineage also gives rise to the erythrocytes and the platelets. All right. We're going to focus now on the lymphoid lineage. All right. That lymphoid lineage now is going to be a part of our acquired immune response, and how that acquired immune response differs, excuse me, from the innate immune response is that the acquired immune response targets very specific pathogens. So in terms of that, you're going to have a particular B cell that will produce antibodies that will target just one bacteria. All right, it won't tag anything else for the immune system to destroy. All right. Acquired immunity is very specific, meaning if you're infected with the measles virus, your acquired immune system will produce the necessary components to destroy that measles virus. And then if you're exposed to it again, assuming you survived the first round with the measles virus, your immune response is going to be much faster so that you won't actually get sick even though you've been exposed to the measles virus. All right? That's kind of how the concept of vaccination is going to work. And we're going to talk about vaccination next week specifically, but we will talk about the components of the immune system that are going to be involved in that this week, all right? So in terms of that acquired immunity, this is going to be our third line of defense. The more you are exposed to a particular pathogen, the better your immune system gets at fighting it off, all right? That's the difference between that and the myeloid lineage. The myeloid lineage with the innate immune system, it doesn't matter how many times that neutrophil encounters that particular bacteria, you'll have the same response each time. This, the third line of defense, the more that you're exposed to the particular pathogen, the greater your immune response is. All right? So in terms of that lymphoid lineage, we've got the B cells, the T cells, and the natural killer cells that are going to be produced. The B cells specifically are going to give rise to antibodies. Those antibodies are going to work at a distance. So those antibodies will be secreted into the circulation. They'll go to the site of the infection. Antibodies can target then that particular pathogen. And this is where we get some overlap between the innate immune response. Because remember when we talked about complement, there was an antibody that bound with complement. Okay? So in terms of that, B cells work at a distance. T cells and natural killer cells are referred to as cell-mediated immunity or direct immunity because you get direct cell-to-cell contact with either the T cell or the natural killer cell and the invading pathogen. Okay? So in terms of our cells that we're going to concentrate on, this week I'm going to focus primarily on the B cells. We'll get into the T cells and natural killer cells a little bit later, and by later I mean next week, all right? So in terms of our B cells are often referred to as the humoral response, all right? And you may have heard long ago, maybe your grandparents, talking about being in good humors, all right? That's kind of what this is referring to, is the humoral response, all right? So if your immune system is working, you're going to be in a better mood, you're in good humors. Humoral also, it gets to the fact that we're working at a distance here, okay? So in terms of those antibodies, they have to go to other sites in order to be effective, all right? So what we're going to have kind of a brief overview of how the B cells work. I'll give a brief overview of how the T cells work. The B cells, what you're going to have happen is they're going to recognize an antigen, All right? And that antigen is essentially going to be those little markers on the outside of our microbe. Helps if I finish spelling it for you first. The antigens are those PAMPs maybe that are on the outside of the bacteria. And essentially what happens, that B cell is going to latch onto that, and then our B cell, through a series of steps, is going to become activated. All right? And there's going to be more associated with B cell activation that I'm going to want you to know about. But for right now, we're just going to call that B cell activated. Once that B cell is activated, it is going to differentiate, meaning it knows what it wants to be when it grows up now. All right? It's going to differentiate into a plasma cell. All right? And that plasma cell, this is our nucleus, all right, is going to secrete lots of antibodies. Okay? Those are the Ys that I'm drawing here. These are representative of the antibodies. All right? In addition to generating a cell that can fight the infection immediately, that B cell is going to create a memory cell. All right? And that memory cell is going to activate and start producing essentially a plasma cell once it recognizes that pathogen again. Okay? So we're talking about recognizing a very specific antigen on the outside of either a virus, although antibodies are usually more bacterial mediated, it can also be viral. All right? It's recognizing something specific, B cell becomes activated, makes the plasma cell that makes the antibodies, and the memory cell, which then will go and become a plasma cell if it encounters that antigen again. This is the specificity and the increase that you get associated with acquired immunity. Okay? So we've got our B cells, all right, and how they work. T cells, just kind of general. Are going to be cell-mediated immunity. All right. Again, with our T cells, that T cell has to be activated. All right. And there are going to be a number of different factors involved in activating the T cell. And this is going to be another area where we're going to interact with the innate immune response, because a lot of times those phagocytic cells, like the macrophage or the dendritic cell, are considered antigen-presenting cells. And those are going to come along and essentially activate our T cell. But in terms of the T cell, we need to have an antigen-presenting cell involved in this process. Don't worry about the details just yet. We'll go over that in more detail next week. All right. But again, then, our T cell, once it's going to become activated, it can be activated to what's known as a cytotoxic T cell. And that's going to kill the cell directly that is either invading the body, if it's bacterial, or more often what we have happen with T cells, our T cells usually are going to be the ones that are going to target virally infected cells within your body. So remember, viruses have to get into your body. They take hold and they use transcription and translation machinery. Those T cells are going to knock out those cells so that they'll shut down production of the viral particle. Okay? But in terms of the T cell, we're also going to have a memory cell that's generated. Okay? And that's the part of the innate immune response that's going to be unique, is we're going to be generating memory cells. All right? If you have any questions, please let me know.